For decades, physicists have debated a profound question: does consciousness play a role in quantum mechanics? Experiments like the double-slit interference and the delayed choice quantum eraser show that when a quantum system is isolated, its wave function remains intact. However, once an observer interacts with it, the wave function collapses. According to the Copenhagen interpretation, wave function collapse is simply triggered by an external disturbance, not by human consciousness. John von Neumann, a pioneer of quantum mechanics, questioned this assumption. He argued that if measuring instruments themselves are made of quantum particles, then their interaction with other quantum particles should also follow quantum laws, meaning the collapse process should not be purely random. But here's the puzzle. Quantum mechanics is based on probability, yet the collapse event appears absolutely random, a contradiction. He suggested that wave function collapse involves the transfer of quantum information to human awareness. Since human neural activity might originate from quantum interactions, our brain's microparticles could exist in superposition, potentially forming quantum entanglements with external particles. Thus, von Neumann theorized that when human consciousness absorbs quantum information, it forces the wave function to collapse, something that might not happen in the same way for animals. Humans, with their advanced consciousness, conduct perfect measurements, leading to strong quantum decoherence and wave function collapse. Animals, like pigs, may not process measurement information as precisely, leading to imperfect measurements, where the wave function might not collapse completely. Crazy, right? Physicist Eugene Wigner supported von Neumann's view in 1961, proposing a thought experiment known as Wigner's friend. However, he abandoned his own idea in 1987. Modern physics tends to support the view that the observer does not necessarily refer to a conscious being, but rather to any measurement process that creates an irreversible record. Before measurement, a quantum system evolves reversibly according to the Schrödinger equation, but after measurement, it transitions into an irreversible classical state. Therefore, the boundary between the quantum and classical worlds can be understood as the shift from reversible evolution to irreversible evolution, a transition triggered by measurement rather than the observer's consciousness. In fact, the double-slit experiment conducted by Austrian physicist Anton Zeilinger in 1999, using fullerene molecules instead of electrons, has already demonstrated the view. By 2011, a quantum mechanics survey conducted among 33 experts, physicists, mathematicians, and philosophers, found that only 2 supported the consciousness-based collapse hypothesis. So, while the idea of consciousness collapsing the wave function is fascinating, the prevailing view is that unless a theory can be experimentally tested and falsified, it remains on the border between physics and philosophy. Next time you think about quantum mechanics, remember, you might be part of the equation.